Today we're talking about structural repair, practical, repeatable ways to restore the shape and meaning of your data after structure problems, whether fragmentation, partial loss, collapse, or corruption. This episode is hands-on and example-driven. You'll get a repair pattern you can apply to real incidents, plus engineering and organizational practices that make repair predictable and safe. Let's begin with a simple framing. Repair is not just about fixing values. It's about restoring guarantees, keys, relationships, types, and invariants, so downstream systems and people can trust the data again. Good repairs are scoped, auditable, and reversible. Bad repairs are quick hacks that introduce more ambiguity and more incidents down the road. Here's a common scenario. An orders table experienced a bad backfill that duplicated order IDs and set amounts to free text for a range of days. Reports were wrong, reconciliations failed, and models degraded. How do you bring the system back without making things worse? The approach I recommend has 4 phases: triage, reconstruct, reconcile, and harden. Phase 1. Triage. Don't rush to transformations. First, define the blast radius. Which tables, partitions, and time windows are affected? Which downstream consumers read that data? Capture a snapshot. Export the current data and keep immutable copies. Identify authoritative sources, backups, upstream systems, payment gateways, or append only logs. Document the symptoms and create a simple incident checklist so everyone knows the scope and expectations. Phase 2. Reconstruct. This is where you rebuild the truth. Depending on the failure mode, you'll either replay from reliable sources, rederive fields from alternate datasets, or reconstruct keys using deterministic logic. For example, if order ID was corrupted, you may be able to recompose it from merchant ID plus timestamp sequence if those components remain intact. If amounts were overwritten, recover from payment processor logs or archived snapshots. Always prefer canonical sources and deterministic transforms. Avoid heuristics that guess values unless you flag them explicitly as imputed. Phase 3. Reconcile. Once you have candidate repaired records, reconcile them against known good aggregates and business metrics. Run reconciliation queries. Do totals match previous audited reports? Do uniqueness and referential invariance hold? Create a repair sandbox where analysts can compare prefix and postfix views side by side. Iterate on transformations until reconciliation passes for critical KPIs. When possible, write fixes as idempotent patches or replayable jobs so the repair is repeatable and testable. Phase 4. Harden and restore trust. Don't stop at fixing the data. Fix the system that allowed the problem. Add validation at ingestion. Enforce key constraints or contract checks, and add monitoring for the invariants that failed. Publish a post-mortem with root cause analysis, the scope of impact, and the exact steps taken to repair. Communicate with downstream teams and consumers. Transparency rebuilds trust faster than silence. Now some engineering details that make repairs safer. Use immutable snapshots. Before any repair, take an immutable snapshot or export of the affected partitions. You'll thank yourself when you need to audit or roll back. Write idempotent repair jobs. Design patch jobs so running them multiple times or rerunning after a failure leads to the same outcome. It reduces accidental corruption during the repair process. Maintain replayable ingestion. If you can replay raw events in order, you can reconstruct state deterministically. Event-sourced ingestion or append-only logs make reconstruction straightforward. Add golden record backups. Maintain periodic golden snapshots of critical entities, customers, orders, products. These provide a reference when primary data drifts. Test repairs on a staging copy. Run reconciliation and acceptance checks in a staging environment before rolling changes to production. Operational practices that matter. Create runbooks for common structural failures, partial loss, duplicated keys, malformed types. A good runbook lists who to call, which artifacts to collect, and the minimally safe repair steps. Assign ownership and SLAs for domain entities. When someone owns the customer or order domain, they're accountable for repairs and for preventing future incidents. Practice chaos or incident drills for data systems. Rehearsing a repair on a non-production snapshot trains the team and reduces repair time during real incidents. Make repair work collaborative. Involve the data engineers who run pipelines, the product owners who understand business invariants, and analysts who can validate outputs. Let's cover a few tricky cases and how to approach them. Ambiguous reconstruction. When multiple plausible values exist, don't overwrite blindly. Impute conservatively, flag imputed values, and surface them to downstream consumers so models or analysts can treat them differently. Partial datasets without authoritative sources. Use triangulation. Combine multiple weaker signals, logs, caches, external API calls to build a best-effort reconstruction and mark confidence levels. Large-scale rekeys or merges. Plan migrations as reversible multi-step processes. Publish mapping tables, run dual-write windows, and support backfills that can be rolled back cleanly. Finally, prevention is the most cost-effective repair. Invest in schema contracts, validation-at-ingest, lineage, and automated reconciliation jobs that compare expected totals across systems. Enforce migrations through CI with synthetic or production-like data. And remember, restoration is organizational as much as technical. Clear ownership, documented processes, and transparent communication reduce repair time and the chance you'll need repairs again. To wrap up, structural repair is a disciplined activity. Triage to limit damage, reconstruct from authoritative sources, reconcile against business metrics, and harden systems so the same failure doesn't repeat. Keep your fixes idempotent, auditable, and reversible, and treat trust restoration as part of the repair itself.